previously we were talking about atomic theory, the explanation of why matter does what it does, and we were looking really far back in time at philosophical ideas, and eventually how we got to the first scientific model of the atom brought to us by John Dalton. Now remember, John Dalton's model of the atom was essentially that atoms were tiny little spheres that were solid, that were able to connect to other things during chemical reactions, combine to form compounds, and those little pieces were indivisible. This was a mainstream accepted idea because it had evidence to support it. And that evidence came in the form of studies about combinations and ratios within gases. It wasn't until around 1897 when things started to change. This idea of the model of the atom held quite well for chemistry, but new experiments were starting to take place with the advent of electricity being able to be used. And so the experiment we're going to focus on in this video is brought to us by a physicist by the name of J.J. Thomson. Now, J.J. Thomson was doing studies with something that was called a cathode ray tube. If you're my age or older, you definitely know cathode ray tubes. Cathode ray tubes actually were what we used to develop all TVs and monitors. If you've ever seen an old TV that looked something like this, or a monitor or a lap or something like that, it was essentially running with a cathode ray tube in the back, and that was shooting beams and creating the picture that we ended up seeing here. Quick side note, my uncle used to have a big screen TV. It was the first big screen TV I had ever seen, and it was run by a cathode ray tube. I swear, it was about like 4 feet deep just to get like a 40-inch screen. It was crazy to think what screens used to be and what they are today. But this cathode ray tube originally looked a little something like this. And so this example is very similar to what J.J. Thomson would have used, and it's essentially a glass tube with all of the air vacuumed out. So there is a complete vacuum on the inside. You put an element that's connected to an electricity source, and it ends up shooting beams of what appeared to be like light, but nobody really knew what was going on inside. And that's why people like J.J. Thomson were actually studying it to see what was going on. So let's understand what he was doing in his experiment. So this is my example of a cathode ray tube. And what they were finding is they would take their element and they would put whatever element they wanted to deal with in the back. And then they would connect this to an electricity source, and that electricity source would then cause the cathode ray tube to shoot a beam straight to the other side. Now, J.J. Thomson was a pretty clever physicist, so what he decided to do was actually measure what was called the charge to mass ratio. And he found that this had about 1/1000th the mass of an atom. But he found that it actually had a charge. And in order to figure out what charge it had, he devised another experiment. So one thing that they understood at this time was the idea of how charges worked together. So what he decided to do was take a plate and make that plate positively charged on one side, and then on the opposite side next to his cathode ray tube, he took a negatively charged plate, and what he wanted to do was see what was going to happen when he when he turned on the cathode ray tube and shot those beams. What he found is that every time it curved, and it always curved towards the positive side. It curved away from the negative side. And so this clever little experiment actually told us that this was a negatively charged object. So he knew he wasn't dealing with light because it did have a mass, even though it was really, really tiny. He knew it had to have a negative charge due to these plates. And this leads us to what he actually discovered. something that has a low mass, something that has a negative charge, and ultimately this leads us to what we know as the electron. So the electron was what J.J. Thomson actually discovered. And so the electron he originally called a corpuscle, but now we understand it as this tiny little thing that has a very high negative charge in comparison to its size. So when J.J. Thomson came out with this idea, it all of a sudden shattered the view of Dalton's model of the atom. And the reason why is because Dalton said that atoms were indivisible, whereas J.J. Thomson was able to describe that it actually wasn't indivisible, that you can actually break it down into smaller pieces, and there are fundamentally tinier things than the atom itself. So this new model that J.J. Thomson came out with became called the Plum pudding model. Now, this may not make a lot of sense to you if you are not from Great Britain, but it's important to understand what plum pudding is if you are like J.J. Thomson and from Great Britain. It is what we would normally call cake, and so it is a dense, cakey substance with little plums stuck on the inside. We call his model the plum pudding model because he described it as a positively charged sphere that had little electrons scattered throughout, much like plums scattered throughout a cake or a pudding. You might think of this better as like a chocolate chip muffin model. Think of a muffin. Now, instead of it being like muffin shaped, make it a sphere. And then there's little tiny chocolate chips all scattered throughout. The chocolate chips would be like the negatively charged electrons that J.J. Thomson discovered. And the cake itself would be like the positively charged piece that makes up the rest. And so the model that he came up with all of a sudden started to change the way that people were looking at the atom, and it led them to wanting to know more. And so that's what we're going to come to in our next video, is how we started to discover new aspects about the atom. So thanks for watching, and I'll see you next time.